రాగే సార్
మా ఇప్పుడు ఎట్లా ఉంది వాయిస్ ఓకేనా?
Yes, sir.
ఓకే వీడియో ఆఫ్ చేసేయండి.
ఓకే
ఓకే
సో స్క్రీన్ కనపడుతుందా సెడిమెంటేషన్?
సార్ ఇప్పుడు వచ్చింది. ఎస్ సార్ వచ్చింది.
Yeah, today we'll discuss two topics ma. One is sedimentation and another one is centrifugation. Okay, so what is sedimentation?
Yes.
Means like you know already, it's a basic separation technique of solid and a liquid. So the main important principle behind this sedimentation is to separate any suspended solids in a liquid. You need to allow it for some time. Like for example, it depends on the density of the particle and the density of the fluid. Okay, so the main force of
సార్
this
కట్ అయిపోతుంది సార్ మీరు వాయిస్
వాయిస్ క్లారిటీ లేదు.
వినపడట్లేదా?
మనీ
ఎవరికి వినిపించట్లేదు అక్క, అందరికి అలాగే ఉంది
సార్
సార్
ఒక్క నిమిషం.
సార్ మీరు ఆడియో బ్రేక్ అవుతుంది సార్.
బ్రేక్ అవుతుంది సార్ మీ వాయిస్.
చెక్ చేస్తాను ఒక్క నిమిషం. ఇప్పుడు ఎలా ఉందమ్మా, వినపడుతుందా?
ఓకే
Yes,
సార్
sir.
ఎస్ సార్.
సో నెట్వర్క్ ప్రాబ్లం ఉన్నట్టుంది.
అవును సార్ అదే
స్టార్ట్ చేద్దాం. So sedimentation means, so if you want to separate a solid from a liquid, you need to allow it for some time. Like the main force behind the sedimentation is the gravitational force. So the gravitational force is downwards, and the another force of this particle is the buoyancy force. If you see the figure here, so this one is gravitational force and the remaining are all the drag forces. So that means the buoyancy forces. So whenever it gets the equal force, that means the gravitational and the drag force is equal, then it gets terminal velocity. So అప్పుడు మనకి ఏంటంటే అది సెటిల్ అవుతుంది అనమాట. సో ఇక్కడ ద మెయిన్ I mean like if you want to know the sedimentation coefficient means you need to know the density of the particle and the density of the fluid. So along with that you have to know about the viscosity of the fluid. For example, in downstream the viscosity of the fluid means almost the like a we use it is not, it's not a matter like if you want to know the viscosity of other fluids means, so no need to worry, because in downstream we use only the water and other particles which are present in the fermentation broth will be calculated. But the thing is, this sedimentation is not that much useful for downstream processing. So that means the downstream processing means, you know, the separation of the particles which are produced during the fermentation. But with the help of sedimentation, we cannot separate the particles. We can separate the particles, but it takes a lot of time. Why? Because the force behind this sedimentation is only the gravitational force. Based on the gravitational force only, we can separate. So if you see here, like the densities of fluid, the difference between the densities of fluid, the particle density and fluid density. Because of that, we can know the time required for the sedimentation. So if the value of the this, I mean, like difference between density of fluid and a density of particle is small, then it takes lot of time. This is more means we can separate the particle with the less time. So that is main reason behind the sedimentation. Okay.
Okay.
The next one is, if you see the example, like we already, I mean, like, sorry. So I already discussed that this is not effective tool for recovery of the product, and it is mainly used after the separation. So if you want to release the effluent to the environment, before releasing the effluent treatment, you need to separate the slurry. That means the suspended solids from the slurry. So at that time it is useful. So if you see this point, it will be indicate that, I mean, like why the sedimentation is not important during the downstream, but it is useful only at the time of effluent treatment. Before releasing the effluent into the environment, you need to separate the suspended solids by using sedimentation. If you see the theory of the sedimentation, we already discussed that the drag force and the gravitational force will be influence the particle, I mean, like a settlement. That means whenever it attains the terminal velocity, the terminal velocity is nothing but the equal force of gravitational and, I mean, like upward force is drag force. Whenever it gets equal, then it attains the terminal velocity. At that time, the particle will be in a constant, I mean, like it settles. That means the maximum constant velocity acquires. So the terminal velocity mainly depends on the size of the particle, then the shape of the particle, the density of the particle, and density of the viscosity, density and viscosity of the fluid. Whatever the fluid that we are having in a broth, the densities of the fluid also influences the terminal velocity. And the final important one is the gravitational force that you know. So these are all the some of the important points before, I mean, like going into the sedimentation. You need to know, so what are the forces that are involving in the sedimentation. The first one, important one is the gravitational force. Based on the gravitation only, sedimentation occurs. So why the, I mean, like terminal velocity occurs means whenever it gets equal means the upward force and the downward force equals, and at that time it gets the terminal velocity. The terminal velocity mainly depends on, these are the important points. Then next we'll see this is actually the equation for terminal velocity. Mu t is equal to dp square. dp is nothing but it's a diameter of the particle 2g rho p minus rho f. You know, this is the density of particle and the density of a fluid. And 18 mu. Mu is nothing but the viscosity of the fluid. So based on this, we can calculate the terminal velocity of the particle. So if you see here, if you want to observe the sedimentation, how it occurs means, so if you take the cylindrical tank, so here the cylindrical tank consists of the slurry. Slurry is nothing but it contains the solids in the liquid. So we can divide into 3 stages. This is the initial stage. This one is initial stage, and this one is intermediate, and this one is a final stage. So if you see the initial stage, during the initial stage, the solids and liquids are present. We cannot differentiate the solid and the liquid because the terminal velocity, it does not occur at the initial stages. So during the process, if you see here, we can observe the, like different zones. At the bottom of the cylindrical tank is consist of the rich solids. That means these solids attains the terminal velocity. And if you see the thick suspension means it is richer in a solid and the poorer in a liquid. And if you see the another one above the thick suspension, that is the slurry. That means the whatever the slurry that you have taken initially, that is the slurry. And above the slurry, then we also observe the clear liquid, which does not contain the solid particle. So during the intermediate stage of the sedimentation, we can observe these are the zones. That means solid zone. This one is a solid zone. The solid zone means the solids which are attained the terminal velocity will be settled first. That means the difference between the fluid densities and a particle density more means those particles will settle first. The remaining will settle later. Based on that only, we can say the sedimentation of the particle. Then after that, this is the final stage. During the final stage of the sedimentation, here we can observe two zones only. The bottom zone is solid, richer in a solid. Above that is a clear liquid. All the solids which are present in a slurry will be deposited at the bottom of the cylindrical tank. That is due to the terminal velocity of the particle. And the remaining one above this is clear liquid. So this is the batch sedimentation. We cannot disturb during the process. So that's why we can call it as a batch sedimentation. This is the example of the sedimentation. By using this, we can explain how the sedimentation occurs, how the solids are getting settled during the process. So why remaining solids are getting settled, when compared to other solid particles, because the difference between the densities of the particle and the densities of the fluid. Based on that only the settling or the terminal velocities depends. Based on that, the solids will be settled. So this one is, we can call it as a batch sedimentation. If they ask about the sedimentation, you need to write about all the topics. What is sedimentation and how it occurs and what are the forces that are involved in a sedimentation process. So why the terminal velocities occur, and also that how it influences the, what are the parameters that influences the terminal velocity and the batch process. We can explain this cylindrical tank experiment, like we can clearly get the idea about batch a sedimentation process. So this is about the sedimentation. The next thing is centrifugation. So you already know, so what is centrifugation? The simple difference between the sedimentation and a centrifugation is, it's a, we are calling sedimentation is the settling of the particle is only due to the gravitational force.
Gravitational force.
Yeah, but in case of centrifugation, there is another force that involved in a centrifugation is the centrifugal force. Along with the gravitational, there is a centrifugal force. Both are same, sedimentation and centrifugation, but the difference between sedimentation and centrifugation is the another force that involved in a centrifugation is the centrifugal force, which is perpendicular to the gravitational force. So if you see the equation here, this is the similar to the terminal velocity of the sedimentation, but the only thing here, in place of g, there is a acceleration, that is a. That means A is nothing but omega square r. Omega is nothing but the angular velocity, or is the radial distance from centrifuge to the particle. So because of this, centrifugal force occurs. So this is the equation for terminal velocity of the centrifugal. I mean, like when you are using the centrifugation, if you want to, I mean, like get settled during the centrifugation. So because of this, the particle will be settled. Okay. So the next, I think you already know about the centrifugation, but the principle is the separation of the solid and a liquid. Here, when we use the centrifugation is, here if you see, centrifugation is alternative method when filtration is ineffective, because we can separate the solid, I mean like from a liquid by using filtration. If you want to separate solids which are, I mean, not separated by the filtration, at that time we use centrifugation. Why? Because the size of the pores in a filter cloth and the particle, if there is a problem with that, at that time we use the centrifugation. So because of the small particles that are present in the slurry, by using centrifugation, we can effectively remove the, I mean, like small particles from the slurry. So that is the main reason, I mean, like behind the centrifugation in a downstream process. So we already discussed about the pre-treatment. So pre-treatment మీకు ఇంతకుముందు చెప్పాను. So flocculation, coagulation చేస్తామని. So flocculation, coagulation చేస్తే మనం ఏం చేస్తాం? There we can increase the size of the particle. So the size of the particle increases means that the densities of the fluid and a particle also increases. So అప్పుడు ఏమవుతుంది? Terminal velocity, I mean, తక్కువ టైంలో సెటిల్ అవుతుంది. అంతే కదా?
Yes, sir.
ప్రీ ట్రీట్మెంట్లో ఏం చెప్పాను? కోయాగులేషన్, ఫ్లాకులేషన్, మనము స్మాల్ పార్టికల్స్ ని ఫ్లాక్స్ గా ప్రిపేర్ చేస్తాం. ఎందుకంటే ఇక్కడ రీజన్ ఇదే. సో స్మాల్ ఫ్లాక్స్ బిగ్ ఫ్లాక్ గా ఫామ్ అయ్యి ఏమవుతుందంటే we can separate.
Sir. Hello, sir.
Yes.
మీటింగ్ నో లాంగర్ ఎగ్జిట్స్ అని వస్తుంది సార్. మళ్ళీ ఇంకొక ఫ్రెష్ గా చేయాలి.
అయిపోయిందా టైం?
టైం అయిపోయింది సార్.
నేను చేస్తాను. అయిపోయింది. కట్ అయిందా అందరికి?
Yes, sir. No, sir. It has shown that
upgrade
it has shown that the meeting has no longer time.
వీడియో ఆగదు.
అసలు మళ్ళీ
continue sir, continue.
ఓకే,
కంటిన్యూ
Continue,
సార్.
Continue, sir.
ఏదో మెసేజ్ వచ్చింది.
It says the meeting has no longer time limit. Sir can continue.
ఓకే,
you can.
ఒకసారి యూ కెన్ కంటిన్యూ.
ఓకే మా కంటిన్యూ చేస్తున్నా. సో హియర్ ఎక్కడ ఉన్నాము? ప్రీ ట్రీట్మెంట్. సో ఫ్లాకులేషన్, కోయాగులేషన్ కూడా మెయిన్ రీజన్ ఏంటి అంటే, if you want to decrease the energy requirement for centrifugation, you need to do the flocculation and coagulation. At the time, what happens means the flux, the size of the particle. We already know that the parameters which are influence the terminal velocity is size of the particle and the densities. So because of the size, the density of the particle and the fluid difference, I mean like in difference between particle and the fluid density will be more. If the difference is more, the terminal velocity also gets affected. Because of that, with the less time we can separate the particle with the help of centrifugation. That means we can reduce the energy requirement for the particle to be separated by using centrifugation. So this is the main reason behind the pre-treatment. So you know the principle behind the centrifugation. So why we are using the pre-treatment for separating the small particles with the help of centrifugation. The next we'll see the different types of centrifugations. So the different types of centrifugations here, we have three different types of centrifugations in general. in the industry, we use tubular bowl centrifuge, disc bowl, and basketball centrifuge. So first two are similar one. I mean, like the operation and other things are similar, and the last one is basketball is compared to first two. It's a different one because it's similar to the filtration process. There we use the filter cloth, but in case of tubular and a disc ball, we cannot use this. I mean, like filter cloth. We'll see how the tubular ball and disc and basketball will be operated. The first one is tubular ball. So this one is tubular ball centrifuge. So here we have the motor at the top of this. Sorry. Here we have the motor at the top. So if you see, this one is the cylindrical tank which rotates during the centrifugation process. This one, this tank. Feed enters at the bottom of the tube. So whenever the feed enters into the cylindrical tank, so when it is rotating, here this tubular bowl is mainly for two things. First one is heavy and light liquid separation, heavy, light liquid, and the solids. But the thing is, if the sample contains the 10% of solids, means then it is useful. If the solid concentration is more than 10%, this is not the suitable one to separate the solids by using tubular bowl. So that is we need to remember. Can I explain again? Here we need to separate heavy and light liquid. That means two immersible liquids. And along with the two immersible, the 10% of solids also will be there, means we can separate. If the more than 10% of the solids present in a sample, we cannot use the tubular bowl. So this we can use another technique to separate the solids. So the operation, if you see here, when the motor rotates and the feed enters to this cylindrical tank, here if you see, the heavy liquid will be thrown towards the walls of the cylinder. The light liquid will be concentrated near to the axis of this cylinder. So if you see here, when it raises, then it will be separated as a heavy liquid. At the center, we can separate light liquid. And another important point is we can separate the solids at the bottom of the cylindrical tank. But thing is, during the process, we cannot separate. After the completion of the process, we can remove the solids by applying washing or some other techniques. So that is the main reason behind this tubular bowl, to separate solids. The disadvantage of this, I mean, like tubular bowl is, if the concentration of the solids is more than 10%, we cannot use it. So this is mainly used to separate the heavy and light liquid and solid concentration less than 10%. The operation is similar. When it rotates, the heavy and light liquid will be separated from the feed because of the density difference of the liquid and the particles. So because of that, we can separate. That means the densities of the fluid, light liquid density is different, heavy liquid density is different. So because of that, I mean, like collection also, the place of the collection is also different. So it moves, I mean, like it throws towards the walls of the cylinder. That means the heavy liquid. At the center, we can collect the light liquid. So this is the main operation, I mean, like process of this tubular bowl. You can also see the some of the points, other points. we can operate with the speed 15,000 RPM. We already discussed that that's 10%. The size of also they have mentioned. And another major disadvantage is it's not efficient one to separate the solid particles with the high concentration. So that is the main disadvantage with the tubular bulb. The next one is disc bulb. It is also similar to the tubular bulb. Here, if you see, the feed enters at the top. There, feed enters from the bottom. So here also we can separate heavy and light liquid. The concentration of the solids is not like a 10%. We can separate solids up to 15 to 20%. But the thing is, we cannot separate if the sample contains heavy loads of solids. This is also limited solid separation. I mean, like from the liquid. You can separate with the help of disc bulb. Limited solid concentration particles will be separated with the help of disc bulb. Here also same thing. When it rotates, the motor is at the bottom. The feed enters from the top. There in this tubular bulb, it reverse. So here also we can separate the heavy and light liquid that is towards the walls of this cylinder, and the light liquid also concentrated at the center. But the main difference is here we use the discs which contains the cone-like structures. Here there is an opening. When feed enters to this process, it enters to the each cone of like discs, and it rotates. The separation takes place with the help of densities. Difference in a heavy liquid density, light liquid, and a solids. The principle is same, but the internal equipment is different. In order to increase the solid liquid separation, there is provision to inside the disc here when compared to the tubular bulb. There is in tubular bulb there is no disc there. So because of the discs, we can increase the separation of the heavy and light liquid and along with the solids. So that is the main reason behind the disc bulb centrifuge. Okay. The next one is basketball. This is the similar to filtration. Why we are calling filtration is, why is it similar to filtration is, here we use the perforated basket. That means it's similar to the filter cloth that we use in a filtration process. This is perforated basket. This one is basket. Actually this rotates. Rotate out. So at the bottom motor will be there. It rotates. It will rotate out only. So when the feed enters to the basket, the solids are separated. Yes. These are all the solids. And the liquid part, that means along with the solid, we can separate the liquid separately. That is as a filtrate. That's why we can also call it similar to the, we can also say that it is similar to the filtration process. But the thing is, here motor will be there, and a motor along with the centrifugal force. We are inserted the perforated basket. Because of the perforated basket, solids will be separated. If the concentration is more, also we can separate. There we can deposit here. Like this, we can separate the solid particle. Remaining will be separated. I mean collected separately. So this is basketball certificate. We have three different types: tubular bowl, basketball, and disc bowl. Okay. So another topic is last one. We have relative centrifugal force. So sometimes what happens is we know RPM. Everybody know that 6,000 RPM, 10,000 they'll give during the centrifugation. That gives only the speed of the centrifugation. That means it tells the speed of the rotation per minute. If you want to know the centrifugal force, you need to know about the RCF. RCF is nothing but relative centrifugal force, a G number. We can also call it as a G number. We can also call it as, writing is very difficult. Okay, so G number. So how you calculate the G number means, if you know the RPM, if you want to calculate centrifugal force, this is the formula actually. RCF is equal to, R means nothing but the radius from the center of the axis. They'll give RPM, you know, they'll also give. So 118 and into 10 power minus 7. So based on this, we can calculate the relative centrifugal force. మనకి ఎందుకంటే ఎప్పుడు RPM అనే వింటాం, but sometimes they'll give in terms of G. సో ఇప్పుడు వాళ్ళు G నెంబర్ కొన్నిసార్లు ఏంటంటే 2000 G అంటారు. 2000 G is nothing but that is relative centrifugal force. If you want to know the RPM for that, you can substitute here. ఇక్కడ రాయొచ్చు మీరు. ఇక్కడ 2000 RPM, 2000 G పెట్టుకొని you can calculate RPM. They'll give the R and then RCF also they are given. So with the help of that, we can calculate the RPM. So if they want to know about the RCF, if they give R and RPM, directly we can calculate. So ఏదైనా calculate చేయొచ్చు. ఎలా అంటే వాళ్ళు 2000 G నెంబర్ 500 G అని అంటారు. అది మీరు కన్ఫ్యూజ్ అవుతుంది. మనకు ఎప్పుడు RPM అనేది తెలుస్తుంది. 6000, 10,000 RPM అనేది ఉంటాం. బట్ సమ్టైమ్స్ దే విల్ గివ్ ఇన్ టర్మ్స్ ఆఫ్ G నెంబర్. సో G నెంబర్ ఇస్తే మనం కన్ఫ్యూజ్ అవ్వాల్సిన అవసరం లేదు. G నెంబర్ ఇస్తే ఈ ఫార్ములాను బేస్ చేసుకుని యూ కెన్ క్యాల్కులేట్ ద RPM ఆల్సో. Okay, so this is about the relative centrifugal force. So ఈ రోజుకైతే ఈ చాలేమ్మా. ఫిల్టరేషన్, సారీ, సెడిమెంటేషన్, సెంట్రిఫికేషన్, ఇవి ఈ టాపిక్స్ చాలు. నెక్స్ట్ క్లాస్ లో చూద్దాం ప్రెసిపిటేషన్ రిమైనింగ్ థింగ్స్. సో మీకు ఏదైనా ఉంటే
ఓకే సార్,
ఇది పంపిస్తా స్లైడ్.
ఓకే సార్.
If you want to say anything.
No sir, nothing.
Sir, in the formula, what is mu? 18 mu అని ఇచ్చారు కదా సార్. Q.
Viscosity.
చెప్పమ్మా.
Mu is viscosity.
Yes.
What? అభినవ్ చెప్పమ్మా.
ఇది ఎక్కడ ఉంది ఎంతకి?
అదే
Terminal velocity of the particle.
టెర్మినల్ వెలాసిటీ ఆఫ్ ద పార్టికల్ లో mu అని ఇచ్చారు కదా సార్. అది విస్కాసిటీ అని చెప్పారులేండి.
అదే విస్కాసిటీ ఆఫ్ ద ఫ్లూయిడ్.
ఓకే
Okay sir.
నేను ఇది స్లైడ్ షేర్ చేస్తా ఇప్పుడే.
yes sir.
Okay sir.
నెక్స్ట్
Okay sir.
నేను షెడ్యూల్ చేసి
Thank you, sir.
ఓకేనా?
Thank you, sir.
రైట్ అమ్మా, థ్యాంక్ యూ అందరికి.
Okay, sir.
Thank you,
Okay, sir. Thank you.
sir.
Thank you, sir.